Standard number 2 of the geometry year is constructions. Constructions means we're going to build shapes with just two tools, a straight edge and a compass. This is a compass where you put the point on the paper and you draw a circle with it. So we're going to be able to draw circles, and then a straight edge is just a ruler with no numbers on it. So we can't measure how far we're going. We can just draw a straight line. So from just drawing a straight line and drawing circles, we're going to be able to create pretty much any geometric shape you can imagine with exact precision. Now, exact precision might be a little hard to believe considering that we're not going to measure these lines. We're not actually measuring anything with numbers. And this particular test is probably the only test you're ever going to take in math where there's not going to be any numbers on it. We're not doing any kind of arithmetic or algebra or anything like that. We're just drawing shapes, and these shapes are going to be the exact size we want them to be, even though we don't have numbers. Why are we doing it that way? Because that's the way humans did it thousands of years ago when geometry was first being discovered. They didn't have rulers back then. They didn't have measuring systems. What they did have the ability to do was draw a straight line and draw a circle with a compass. So these tools have been around for thousands of years, just without numbers on them. All right, I also put up here Open Math Reference. Open Math Reference, if you search that on Google, it'll be Math Open Ref. They just use REF instead of reference. MathOpenRef.com. It'll be the first thing that pops up if you search for Math Open Reference. You click on there and you go to the constructions, and it has dozens of different types of constructions that you can do, and it's a really good tool. You click on one of them, and it'll put a new screen up there with a straight edge and a compass on it, and you just keep clicking the next button, and these will move around and draw the shape for you one step at a time, so you can see how all these different shapes are built. And considering that this is remote learning, and it's going to be a lot easier to do it that way. Let's just say that. So, if you go to that website, Math Open Reference, and you click on constructions, you're going to see a lot of this. The very first category is called lines, and then under lines, it shows you how to construct a bunch of different types of lines. So, for this particular standard in geometry, you're going to have to know like 7 different constructions out of the dozens that are on there. So you don't have to know them all, even though some of them are super cool. The most basic one you're going to have to know is how to copy a line segment. So you're basically just going to draw a line with your ruler and then draw another one that's the exact same length, which seems easy because you have a ruler. So if you draw it 6 inches, you could draw another one that's 6 inches. But you got to pretend like there's no numbers on the ruler. You can't just mark off the ruler how far you went and then mark another one. What you do is you use the compass. So this is probably the trickiest part of this standard, is getting your brain to forget that a ruler is meant for measuring length. It's actually the compass that is used for measuring length. So for example, if I were to use my straight edge here, draw a line, and I wanted to know how long that line was, I'm not going to use the ruler to measure how long the line was. I'm going to use the compass, and I'll set one point at one end of the line and then the other, and then adjust it so that my other point is at this end. Now I know that right there is exactly how long that line was. So that's what the compass is used for, is for measuring distance. And then the straight edge is just used for drawing a straight line. All right, so if you go to that Math Open Reference and you click on Copy Line Segment, it'll show you how to make another line segment this exact same length. It'll also show you how to make a perpendicular bisector of a line segment. Perpendicular line to a line that goes through a point on the line. So what does that mean? That means here's your line, here's a random point on the line. You have to draw a perpendicular right through there, so that's exactly a 90-degree angle without a protractor. So You can't eyeball it. You can't just put your straight edge up here and say, that looks about right, and draw a line. No. It's got to be exactly 90 degrees, and you cannot use a protractor. Just use two tools. So that could be a little tricky, but once hopefully I explain it to you, it'll be easy for you if I do a good job explaining it. This next one is real similar to that one. You start off with a line. You got to draw perpendicular through this line from an external point. That means a point that's not on the line. So say like a random point up here. You got to draw a line through this point that crosses your original line at exactly a 90-degree angle. So it's similar to the one before, but the one before the point was on the line. This is one the point is off the line. And then you also have to be able to draw a parallel line to a given line. So you start off with your straight edge, you draw a line, you take a random point that's not on the line, and then you draw a line through that random point that is exactly parallel to this line. All right. And when you go to Math Open Reference, they'll show you 3 different methods on how to do that. One of them is angle copy method. That's the one we're going to use. You don't have to worry about the other 2. So you got to know how to do the angle copy method. Before you can do that, you have to know how to copy an angle. That's why it's called the angle copy method. So that brings us to another section on Open Math Reference, which is angles. In angles, you'll see a bunch of different things you can do, but the very first 2 are the ones you have to know how to do. You have to know how to copy an angle, and you have to know how to bisect an angle. And then as a bonus, I want to show you guys how to make a perfect hexagon inscribed in a circle. Inscribed means it's inside the circle. So essentially you have a circle in your hexagon, the vertex of your hexagon are going to be right on the circle. That might be an octagon, actually. That's too many vertexes. But inscribed means that your vertex are right on the circle. So it would look more like this. So that would be a hexagon inscribed in a circle. And there's a lot of history to this shape. I'll get into it when we get to that later. But you can find hexagons in nature. I think it's Neptune or one of the planets, the North or the South Pole. It has a perfect hexagon on it. Hexagons have been being used since Babylonian times. But like I said, I'll get into that later when we get to hexagons at the end of this section. What I want you guys to do for now is basically have a good weekend. I'm not going to give you homework over the weekend. You're probably the only group in the whole school that took a test during this first week. So you guys you've had a good full first week here. I'm going to kind of give you the weekend off. What I'm asking you to do is to go to that open reference, Math Open Reference is what it's called, Math Open Reference website, and play around with some of these. So you might even like them. This is some of my students last year, this was their favorite standard because we were in class that actually had a straight edge and a compass, and they got to draw a bunch of pictures all week. But you could draw some pretty cool stuff. There's some pretty neat things on there that are possible to build with just a straight edge and a compass. So get familiar with that website, and then next week we're going to use it to learn how to do these things that I just went over today. And then we'll take the test sometime next week, probably not on Wednesday again like this week, probably on Thursday. I might push it up till Wednesday just because there's no numbers on this test and it's just looking at pictures. Basically the test is you just look at a picture and say, yeah, those are parallel lines. I mean, you could probably take it right now without knowing anything about constructions and do pretty well on it. And like I say, I like to get ahead. We've got 7 tests for 7 weeks. So we've got to take 1 per week. And I don't want that 7th test ending up on a Friday on the 7th week because then we have no time to study for benchmarks. So I'm trying to get ahead. I'd like to get our 7th test in at the beginning of the 7th week, maybe even on a Friday of the 6th week. So we have a whole full week to study for benchmarks. So these first 2 tests are pretty easy. It's nice that they gave those to you first. So we can kind of speed through these first 2, especially if you go to this website over the weekend. You're going to learn as much on this website by playing around on your own as I could teach you in class, and that'll give you a real big head start, and then we can keep on moving with the rest of the year. The 3rd test, we start getting into numbers, and it starts to get real after that.